So maybe Dmitri, let's move forward to you. Because I think some of the things that you will be talking about will actually be addressing some of the challenges that Rob has mentioned here. So I think it's a good continuation in any case on how to secure the things that Rob and with his team and Mandiant have been discovering. The floor is yours, Dmitri.
Okay, thank you. I can share now. Perfect. Right, so hopefully you're not starving, and maybe you take some bites. It's lunchtime. I guess you can hear me, and you can see my screen?
Yeah, confirmed.
Perfect. All right, so my name is Dmitri Belotchkine. I'm the Cybersecurity Solution Architect at TrendMicro Europe. And I'll talk about challenges for smart factories in terms of security in today's world. A little bit about TrendMicro. So I guess pretty much majority of the audience know about TrendMicro. Just to say that we are a veteran on security market, IT security, cybersecurity, more than 30 years, leader in cybersecurity for the cloud solutions, and user protection network. And with our mission shifting all the time, we actually pick up on the challenges of connected world. So we see more and more things getting connected, right, and in different ways. And one of the aspects is ICS and factories, of course. So instead of developing the, inventing the wheel, because cybersecurity and the operational side of things, OT, is not actually the same, so we're different worlds. So we decided to join the efforts with Moxa, which is also a company which I think more than 30 years on the OT market. And together we joined forces and found a new company called TX1 Networks, which solely focuses on the security of the smart factories and ICS as well. So yeah, the development is there. OT moves on, and we're talking about industrial 4.0 now, industry 4.0, where things get connected for different benefits. Mostly we look for smart analytics, we look for predictive maintenance benefits. Of course, there are cloud computing involved because things get connected now from the work floor to the cloud. Through different ways communication takes place. We see also the use of blockchain. Telecom plays nowadays quite serious role as well. For example, asset discovery, asset management. We see different technologies being used, and that requires, of course, shift in paradigm for security for the factories. Previous speakers spoke about risk management approach that we all need to take. Make decisions wisely, consciously, do risk assessment, know why you connect one another element to the network at all, and you connect it outside of your network through internet to some other places. So that's all should take place. And of course, there are procedures, but there are also security controls. And the security controls can be physical, can be logical controls. And we offer from TX1 Networks, from TrendMicro, this ammunition that you can use wisely in your practices when you decide, for example, start connecting things. Because if you don't do it consciously, and sometimes it's business decision and then OT security or IT security not aware of this, sometimes it's just lack of due diligence, but things get connected. And when that happens, the whole world gets to know about it. So, for example, Shodan, but there are also other systems which do the indexing of the internet connected things. And it's so easy for not even advanced attackers, but also for the attackers who are maybe state-sponsored to look around and maybe choose specific territory you want to attack and go and search for very obvious things. So here's an example. I was looking for PLC, and you get to see immediately the whole Europe like lit up for different reasons, right? And that's the opportunity for the attackers, because if it's already open, yeah, why don't you go and explore it? So let's go and do that. And I was just looking randomly on the map, and you can see immediately that in different countries you get PLCs connected directly, right? So this one is 102 port, so that's a Siemens, obviously. And you see what kind of device it is, and you can even try and do some commands to it, right? So using S7 protocol in this case. It's also interesting that if you start looking around and you don't know exactly what you see, you can also try to do some geolocation and look on the maps, like Google Maps, right? Because on the same shotgun, you get GPS coordinates. So like in this case, in Czech Republic, I was just wondering, okay, I took the same coordinates. You go and you just explore. And well, you look on the map and then like, okay, what do I see here? And after some careful examination, maybe zooming, you can see that, okay, there are some artifacts which do not belong to this field, obviously, and you start maybe zooming even further, and you get to see that this is probably this part of the critical infrastructure, right? So high voltage mess that you probably found, and you have open systems, so you can try to connect, you can do something with it. So coming a bit closer, and yeah, greetings from the Eindhoven. So the example from the Netherlands, if you go and look for, obviously, like Siemens, something, you can find systems like this. You get to see a number of ports open, some of them recognizable, like FTP and HTTP, but some of them not. And we can take a look, for example, okay, we get ProFTPD version 135, all right. And we get port 3671 open, which is Connect Gateway, OZW772. So after some quick search on the internet, you can find this is easy and secure remote access and plant overview. And you get secure access, secure remote access. That's all good. And probably there is business reason behind it. But hopefully it's being managed from security point of view as well. Because also quick look up on the ProFTPD CVEs, so the vulnerabilities which are already known, you can find them from version 135, you get a bunch of vulnerabilities still open, right? So this is right away the point of attack for the bad guys. And you don't need to be very experienced attackers. So the same shotgun, you can also look for some exploits. So this one gives you, if you don't have understanding how you can speak S7, gives you some modules for Metasploit, which you can download from, again, open source resource and use in your bad activities. So unfortunately, this is the reality. This is what it is. Now, if we look around, there are a bunch of vulnerabilities, of course, in ICS systems, and we all talk about patch management, but well, nowadays we still see a lot of them being discovered every single day. So regardless of the vendor, there is every vendor having vulnerability, so you cannot say one is more secure than others. But what's interesting is that if you look on the types of devices that we see HMIs prevalent in this picture, so 60%, 60+% of the vulnerabilities found are on HMIs. So human-machine interface, why is it attractive? Well, first of all, like in Black Energy case, it's easy to use, right? So if you break in, you have access to HMI, you can do the flip on and off, and that's it. So that's quite easy for attacker. On the other side, if you look in terms of how much attention vendors put in code, in the security of the code of HMIs, unfortunately not much. So on one side, it's not a main revenue stream for vendors, so they use it to sell the main products that they sell. On the other side, many vendors of ICS or OT equipment, they are also quite active now on IoT market, which has different go-to-market base. And we see that the code sharing happens, right? So if you need to come up with a next version for IoT market, and you develop some user interface libraries, which can be then shared with ICS version of your product. And then obviously those bugs which made in a hurry also make it in ICS side. Now from TrendMicro Research, and one of the outstanding teams that we have, TrendMicro Zero Day Initiative, we do research on the SCADA and OT systems, and we see that majority of the problems come from bad management of the input and output in the code, right? So memory corruption is very prevalent. We talk about buffer flow issues, heap management, and so on. Credential management, sometimes hard-coded passwords, sometimes very easy passwords, very short ones that you cannot put the long one. Lack of authentication, quite often. Code injection, which is not only injection of code in IT protocols, but also we see abuse of OT scripting languages like Gamma, for example, and some others. So quick words about Zero Day Initiative. It's a leading vendor agnostic bug bounty program on the market. We do research, but we also purchase Zero Day vulnerabilities from independent researchers, right? So we are comparing to the market, for example, every year we are largest supplier number of CVEs, comparing to Google Project Zero, for example, which is number 2. And this number of CVEs that we discovered, not all of them, but you get the idea that it looks quite impressive. Now, how does it work? So at some given moment, there is a discovery of zero-day vulnerability, so vulnerability in a system or in the code, which is known to some people, but not to the public widely yet, right? So this vulnerability is submitted to a program. We do the assessment, we do due diligence, we see if there is proof of concept, if it's working. Then we talk to vendor, inform vendor about vulnerability. Then vendor at some point also, after evaluation and creation of the patch, they go public and they release the patch. Now, but all this time, there is this vulnerability, which is zero-day vulnerability without patch, known to some actors, not to everyone. So on average for the enterprise market, we see it's about 61 days between we notify the vendor disclosure time and the time when vendor goes public and release the patch. You also see here that, we use the data also to power our solutions to have protection for our customers for exploits which take benefit of this vulnerability before the time when patch is disclosed. Now, then we talk about end day when the vendor goes public and then the vulnerability is patched, well, theoretically. So patch should be applied, and then when attack happens, then it will just, bump into the patch system. Unfortunately, that's not the case, and most of the cases, the attackers, they get to know in the end day. So first 24 hours, when the vendor goes public, there is massive spike of scans and exploit attempts of those systems. So in enterprise world, we do not really believe that we can patch in one day, but when we talk about OT world, then that's completely not the case. So you can expect then massive wave of attacks the first day when vendor goes public. So meantime to patch in SCADA environment. So I told you about enterprise world, it's 61 days. When you look at the SCADA side, it's 146 on average. Again, the data coming from TrendMicro Zero Day Initiative research. And depending on the vendors, sometimes it's quicker, sometimes longer. So if you use one or another vendor, you can see where you're standing at in terms of the time to patch. You can take a look at this URL. So as I said, vulnerabilities get reported every day, and we publish them. You see, sometimes there is no CV, so that's information which we disclose to vendor, but there is no agreement on okay, we go public, right? So let's talk about risks. Of course, there are frameworks and ways how you need to organize your security controls. And not all the time it happens, and not all the time we see that actually it's all organized according to the standards and frameworks. And even if it's so organized, we see very sophisticated attacks, but sometimes very dumb attacks. So let's see how it happens. So Rob talked about Triton. So one of the target attacks, we've seen some others as well. So sometimes it's successful, sometimes not. We've seen a wave of ransomware attacks recently, right? And we see also that the shift of type of attacks towards targeted and pointed attacks going pretty quickly. So if we talk about WannaCry and Petya hitting OT sites, which is kind of side effect of the whole attack. But then later on, like Lokor Goga, we're seeing a handful of victims, which tells us that this is pretty target attack, so it's not being used widely across the world. So target attacks, well, usually the vector of attack is a person. So it's either email or drive-by downloads or browsing, and it's quite easy to get in. And then from there, even if you have disconnection from your information system network and your control information network, still there are some ways to get in, right? Either through the network or maybe through USB, which I'll talk about later. There are also now attacks on the supply chain. So the vendors being attacked and they being used as stepping stone to get in of the other targets, the high-profile targets, usually government organizations or military organizations. Then remote vulnerabilities. So it could be systems on enterprise network, could be data center, internet-facing systems, but also could be systems directly exposed from the work floor to the internet. Could be historian databases, could be OPC servers, PLCs directly, as I showed you before, but some other systems as well. So using vulnerability in those systems, we can get in. USB infection. So I hear quite often air gap environment, and people say, hey, I'm not connected, so nothing can happen to me. But then you need to exchange data somehow. So USB infection is used to actually close this air gap. Also think about vendors, and vendors, they come for maintenance and they usually bring USB sticks as well, or maybe laptops. And if they are infected, they bring it inside as well. So this air gap is basically a fiction. Just to illustrate, quite old, 2007 discovery, a brutal kangaroo. So it's one of the tools leaked from NSS leak, right, as part of Vault 7 leak. Tells you exactly how it happens. So if system A, you can imagine, resides on enterprise network, like in the office, which is office of the factory, and connected to the internet, and there is someone who can be targeted, maybe email, maybe some other ways. And one way or another, they do the foothold on the system A, and system B is in the factory, which is air-gapped. But then they use USB sticks to move data around. So we can see that, well, point of entry will happen on system A. Then when USB stick is entered in system A, the malware will infect this USB stick. Then it will travel to system B by foot. And once it's inserted in system B, it will infect it, will grab the system information, put it back on USB stick. Then the person will go back to the office, will put the USB stick back in system A, which is connected. This malware, which is resident, will get the data from the stick, will share it with the attacker through command control channel, will probably get back some comments based on the data which is leaked, what to do next, and so forth. And so this cycle will continue until you close it. Physical compromise, so sometimes factory, sometimes it can be something else, like critical infrastructure, could be places out there which may be physically not secure properly. But also quite often I hear from customers that they work with a lot of consulting companies, and what they do, well, they usually let people in. They get to work with equipment, so they need to connect maybe their laptops. So first time they do the check, and they whitelist and MAC addresses and some other stuff, and that's it. So this consultant goes away and then come back, and maybe after 1 month time keep working, but it's already checked everything that he has, the laptop, the USB stick, so they're not checking them again. And in the meantime, this consultant, well, traveled somewhere and maybe got infected. So from that moment on, the dormant malware can attack the customer environment. Then infection outbreak, of course, if you have open network and not that much control. So what we can do against it? I would say the vulnerabilities and the exploits which can take advantage of it are quite severe. So the patching is quite challenging, as we know. So what you can think about is maybe virtual patch at the perimeter level, right? So if you have a system which can shield off your environment from the exploits, whether it's known exploits for non-vulnerabilities or exploits for zero-day vulnerabilities, it doesn't matter. So you need to make sure that you sanitize the traffic that comes in. Target attacks also quite prevalent, but not as much as the vulnerabilities, because target attacks, well, it's quite a challenge for the attacker. So you need to know what you do, how you do it. It's much easier to attack vulnerable systems. But for target attacks, it's also good to have maybe a breach detection component in your perimeter, but maybe also inside the breach detection system, which will be able to sense the signs of point of entry, if you can, but also do the correlation of this point of entries with lateral movement, with command control communication, with the data exfiltration that takes place. Because this will help you to shrink the breach window and will force attacker actually to change the strategy and tactics. Because if you start closing command control communications, they will need to move around and create new backends and so on and so on. Then going down to the workflow, network segmentation, many customers I spoke with is very weak point. So quite obviously, if you have flat network and you have no network segmentation, it's difficult to control the communication between your critical assets, but also from outside to inside. Simple way, if you have vulnerability which is exploitable, like in WannaCry case, then it will be a sweep, and in a matter of minutes or hours, your network will be encrypted. Also in targeted attacks, it's a freedom for attacker to move around the PLC cabinets, for example, or from one type system to another if you don't control it. So network segmentation is very, very important. So when we go inside of PLC cabinet, for example, we have usually this architecture. So you have some type of industrial PC and PLCs, and then this PLC cabinet is connected to your production line. The network-wise, there is usually one or another network racks with access switches, which gets which will connect the PLC cabinets between them, but also connect them to the data center, to SCADA systems. So instead of using just OT switch, you can think about maybe a firewall, which will help you to segment the network and control communication between PLC cabinet and production line, but also the outside systems. The other way, how you can protect your vulnerable systems on the work floor is specific virtual page for your critical assets. So you can think about next-gen industrial IPS, which will be able on one side to understand IT protocols and vulnerabilities exploits being shot in these protocols. But on the other side, also understand OT protocols and also protect your PLCs and IO devices from the specific attacks. But also control the communication pattern between the HMI's engineering workstation and your PLC and your IO devices. Because as we've seen in many attacks, attacker usually doesn't know what environment he deals with, and he stumbles kind of over the furniture in the dark room. So if you be able to control the communication on OT protocol level between asset A and asset B, and say, okay, from my HMI, I can only read from this PLC, but from engineering workstation, I can also do write or config comment in the OT protocol, then it will help significantly, because then you will start seeing that the connections, abnormal connections will be blocked and the assets will be protected. There is no network segmentation with industrial IPS. Industrial IPS, at least that we provide, is the layer 2 device, very easy to implement. You can basically, using your current network architecture in the factory, and just connect IPS at the entry point of your PLC cabinet, or maybe from PLC cabinet to your IO devices that constitute your production line. Then another component that you can do is the lockdown of legacy assets. There are assets which run on the general operating system, like Windows. You cannot patch those assets for one another reasons. Mostly it's specific requirements for vendor. But also we see that quite often OT personnel, they are afraid that there will be false positive and security software will block legitimate process. So that's why also I see in the story of Triton from Rob that actually AV and whitelisting solutions, they are not used in the blocking mode. So, which is quite important component, right? So lockdown on 4 levels, in my opinion, is very important. So lockdown on operational level. So you need to create a baseline of the processes running in this specific device, like HMI engineering workstation, because the mutation is not that often on those devices. You cannot expect that something new coming up, like Mimikatz, right? Or maybe PuTTY that appears on this device. Maybe you never use it. So once you lock down the processes, you can already start cutting off those types of techniques in attack. Then lockdown of your data. We've seen attacks which adjust the SCADA recipes, right? PLC configurations. So you need to protect those files. Lockdown of the configuration of the asset. They cannot be able to change the MAC address of the device. They cannot be able to change IP address, DNS settings, registry, and so on. And the fourth component of the lockdown is protection of your USB ports. Intelligent protection, intelligent lockdown. You cannot say we block USB ports. You must be able to control USB ports the way that you open USB ports in specific moments for specific devices, and probably also run just specific binaries from those devices. Make sure that you have procedures for vendors to check the data they bring in USB sticks and allow only those USB sticks in specific moments for specific updates. Yeah, we also have a solution which quite popular amongst our customers, which is basically anti-malware on the stick. It looks like this. Very small factory USB device, which can be used in the periodic security scan of the devices in the factory, which you cannot run anything on, right? So you cannot run whitelisting or anti-malware software on those devices, but you need to periodically check them. Again, after the RMA case when the device came. Maybe you need to check it because sometimes it comes rooted after the maintenance visit of the vendor and so on. So this is quite important. Very quickly, and I'm coming to the end of my presentation, demo on how you can use IPS to prevent like ransomware attack. So I took it from our demo unit. So you see here SCADA or HMI system, which is vulnerable. So you see the WannaCry case, so it's being attacked and compromised. Now you see that IPS is switched off, the IPS, the industrial IPS, which protects this particular system. And yeah, for simplicity, we have this, so there is Metasploit behind, but we have just buttons. So now when we switch on the IPS, okay, so one more time. Now, switch on the IPS. And we see that when we start attack, that this particular device is going to be protected because IPS is now shielding the exploits. So exploits are not reaching the vulnerable systems. So even the system is not patched properly yet, you have this virtual patch on the network level, which will prevent the exploits reaching it. Now, on the other side, if we talk about IO device, and let's say, okay, one or another device is compromised in my control network, and from there they start manipulating the PLC. So here you see the Mitsubishi Q PLC type, and it actually controls IO device. So if we don't have control and IPS is off now, we can launch PLC attack, which will attack the PLC, and you see that the IO device, the engine stopped. So it does not work anymore. Now I switched off the attack and it goes on again. And if I switch on the IPS now, so now PLC is connected through IPS where I can control what kind of command, OT command can I send in MLSEC in this case. And you see that operation is not interrupted. So this is very simple, very effective solution to apply it already today and yeah, start benefiting from it. All right, so featured products I talked about, the EdgeFire GX1 firewall, so layer 3 device you can apply for segmentation. You can do virtual patching with it. You can do asset discovery. You can control IT and OT protocols. And the other device is very lightweight, small device. So this is like version 1 looks like. I don't have version 2, but version 2 you see on the screen. It's kind of the same size. And it's a layer 2 device. You can connect, basically, you take out the cable from OT switch, put it to port 1 of this device and another cable from port 2 back to OT switch, and that's it. You already start protecting your valuable asset, whether it's PLC, whether it's IPC, or maybe IO device. Then I talked about Portable Security 3, so anti-malware on the stick. You can use it. It's OT friendly. You have LEDs, for example. You don't need to be expert and read screens. You can just make a difference in colors. If it's finished working and it gives you the green color, then it's good. If it gives you red color, it means it probably triggered something, and depending on your policy, maybe quarantine files on the stick, and you can do investigation with your security team. The last one is industrial, enterprise, but also industrial IPS device, which is enterprise size. So it's 1U or 2U form factor, which fits in a 19-inch rack. Can be used in network cabinets on the factory, but also in data centers. So that's it from my side. If there are questions, I'm happy to answer.
Well, thank you, Dmitri. Great overview, and as I said, was very complementary to what Rob was talking about, presenting the full kill chain, basically how they've been seeing the actual attack coming in, and then seeking all of the different ways through. You gave many different pointers towards the potential solution to some of those challenges. And I think, well, the two of you were very complementary. So what may be a good exercise is how some of the technologies and the tools that you had and that also Rob has, of course, in this case, would actually help in seeking how we can avoid these types of attacks coming in. Maybe as a quick question to you, Rob, we have one more presenter coming up, and we are completely run out of time. But I got the instructions from a number of people that needed to drop out, that they will continue with the seeking what the recording has delivered afterwards. So I think that allows us to continue probably a little bit, not too long, hopefully. And Bart, I would say, be ready to take this up. So the question to both Europe in the first place, and then to Dmitri. So Rob, you gave this full overview, and I hope you're still there. How can organizations track what you guys have been tracking? What would they need to look for in order to detect all of the things that you have talked about? I mean, obviously not everybody is a Mandiant, and obviously it's a good reason to go for Mandiant, but at least if you can get some pointers on what companies would need to look for and would need to start investigating in their systems.
So I think one of the key things is have a good indication of your network monitoring, right? So if you have any type of network monitoring, and there's many different products, many different ways to do that, I think that's probably the step one, and get a characterization of what's known normal with that. Also understanding, you know, what security controls you have in place today, right? So, I mean, you can go out and purchase additional security controls, but in many cases, the ones that you have in your systems today, the IT controls that are installed and perhaps DMZs and things like that, are not being monitored and not being used. And so I would say, you know, do a full inventory of what you have, begin with that, begin to learn what you can use without going out doing any purchases, then do kind of a gap analysis and say, okay, if we were to get good situational awareness, you know, good visibility into what's going on, what do we need to add to the system to get us full awareness? So that's how I would start. And then, you know, once again, getting a good characterization of what's known normal. And of course, that does predicate, you know, that your system is not impacted today, but getting an understanding of what normal traffic is, what are the flows, what are things that should be seen on the network, and then being able to detect what's not seen. So that's how I would start.
And I think your message came very much true, because if you can see the poll results that I'm sharing you now, so 43% of the answers that we got are indeed indicating the continuous monitoring as one of the primary target things to do. So that's a good thing. So people got your message in any case. Interesting is that they also indicate their security by design, which is, I think, also pretty interesting, especially in this domain of industrial control, because there, as far as we can see, it's not that easy to do a security by design. But also to your point, both the risk assessment and getting a good asset discovery and asset understanding is probably pretty important as well. All right, thanks, Rob. I'd suggest maybe that we'll be in touch in the next couple of days to see how we might be able to set up a discussion, maybe not next week, but then maybe the week afterwards when we continue with these sessions. So thanks in any case, to stay on. And if there's any additional questions, then we'll put them up and we'll send them over. But enjoy the rest of your day in any case.
All right, thank you very much.
Thanks, Sam. Dmitri, regaining back to you. So you gave a very good insight in the way that we addressed what Olivier was talking. We cannot really define what legacy is. So let's just call them old systems. There was a very interesting question that Jacques-Henri has put up on the Q&A in terms of what IT operating system is supposed to be renewing every 5 years. I think in my case, it's about every 2 to 3 years, but yeah, I think it depends whether you are running on Windows or Mac. So I indicated there that what we see is systems which are typically around for 30, sometimes even 40 years. And many of those systems actually have second or even third lifetimes. So in your case, taking that switch into the new normal, if you would need to add IoT, industrial IoT, so new types of sensor technologies, how do we need to deal with them? I think one of the topics that we've heard this morning, for instance, in our 5G webinar, was edge computing, including 5G, to connect devices, so actually going beyond the current network and using public networks. So how do we deal with basically IoT and intelligent sensors to be added to this?
Right. So as I think previous speakers said that, well, risk assessment and risk-driven approach is very appropriate, regardless of the environment. So I think also not a difference in this case. So if you use legacy systems and you need to connect them to the like new world, right? You still need to think about okay, what this system is doing, right? What will be the risk of losing them? What will be the risk of being compromised? What kind of data can be compromised in which way? And then mapping this into the new architecture that you're building, looking for the new vectors of attack and possibly new places in this architecture where you can apply controls. And then you come with a picture, and then you come to see, okay, these are the following risks, whether they come from the fact that the system is legacy and I cannot get any patches from vendor. And by the way, I cannot upgrade the system because OT vendor tells me that it's only certified for that specific operating system, or maybe for the reason that you simply cannot stop the production, right? But you still need to manage those risks, right? It could be, again, misconfiguration, open access, it could be vulnerabilities. You can choose different strategy. You can go and apply, again, depending on the outcome of the risk assessment exercise, you can apply controls close to your asset. You can apply controls on the perimeter. You may mitigate it maybe in a communication layer, maybe with the telecom vendor, because there are solutions for software-defined networks like VNFS-based solutions where you can still apply the same controls, which will scan the traffic, and they will look for exploits, they will do the application control, and so on and so on. It could be in the cloud as well. But yeah, again, it's difficult to say which because it will be specific in each case. But yeah, I would agree with everyone speaking before. Risk assessment first, define your weak points in the current architecture, in the future mode architecture. Think about the gap, define the controls that you need to maybe beef up, maybe you need to add, and then go for the execution.
All right. Thank you very much, Dmitri. Also in your case, we'll be back on the follow-ups in any case.
All right.
Bart,